guys, you guys all were interested in saying like you're coming from different knowledge bases, right? So the purpose of this course is to take you from having like no knowledge on climate science or climate health or anything about the topic to those of you who have been like, I've taken courses in undergrad or I'm passionate about it or are really involved. So this is supposed to be an all-encompassing kind of catch everyone up to understand the basics, if that makes sense. So let's just get in. This is kind of a background in climate science. So some people do a major in this in undergrad. We're going to knock it out in under an hour. But we're going to tie it into health at the same time. So in terms of what we're going to cover today, all right, let's put this. There we go. So here's our objective. So just overall, in terms of what we're going to cover, is just what's really happening in climate science. We're going to talk about what is going on, kind of the story of carbon, how involves us as humans, how we have engaged in the creation of climate change. We're going to talk about kind of how carbon moves in the environment and why that's important to understand, both for solutions, but also part of the problem. And so, what's going on? We're going to reformat kind of like instead of a global warming, we're going to see that this is more of an energized planet and what that means. We're going to talk about how health is involved, and we're going to talk about kind of solutions because this isn't supposed to be just doom and gloom, right? This is kind of I like presenting climate stuff in terms of, this is already decided. These are the facts. How do we solve the problem? And if we don't talk about solutions or ways to engage or ways to become involved, then all we're doing is just, negative Nancy, just rah, 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 all the time. We don't want that. We want people like positive about this and seeing that there's actually hope in something that we can do. So, why do I do this? One of the big reasons I do this is for my family, right? I do it for my kids, for my wife. My wife and I are going to be fine. Big picture, right? We're going to be fine. We're going to go on. We'll live our lives. We're going to be fine. But my kids, and you guys are going to be affected a whole lot more. And I'm worried about my kids, my grandkids. So those are kind of the drivers of why I'm doing this, kind of keep me going. So if we talk about climate change and health, this is a complicated slide, right? There's a lot going on here. But this is from the CDC before the CDC got kind of taken over by the current regime. But there's four kind of major drivers. So if we look at why climate change is happening and how that's impacting health, the four major drivers on the inside are increasing carbon dioxide levels, rising temperatures, extreme weather, and rising sea level. And that combination of what's happening in our climate then goes out and starts impacting things. It leads to more extreme heat and air pollution, water and food issues, increased in vector-borne diseases, increased in mental health issues from seeing the environment go away, whether that's conflict or migration of people because of environmental impacts, right? So those kind of areas then start to impact different diseases. So whether that's respiratory health, neurologic health, whether it's trauma, right? People are having fatalities from different issues, whether that's reproductive health. So all of these are stemming kind of from the core basis of increasing carbon dioxide levels, leading to rising temperatures, extreme weather, and rising sea levels. So let's get into why this is happening, right? Is this even a real thing? Absolutely, it's real, right? The experts agree, but there's a disconnect, right? People don't like, oh, climate change doesn't exist. No, for this course and for everyone else, it exists. But part of it, we have to know the enemy, right? Who are the people who are doubting it? What are they thinking? Well, part of the reason they just don't believe the media. They don't believe politicians. But these people also want clean air, they want clean water. They don't want their freedoms impinged upon, right? They don't want someone to tell them what to do and say that they can't have an internal combustion engine and they have to have an EV. They think this is kind of like natural causes, right? That this is a natural cycle, and we'll talk about that a little bit. And it's really not humans that have done this. But they do think that maybe EVs are depleting the environment. Maybe the electric vehicles we should get rid of because they're taking all the resources. And they're okay transitioning from fossil fuels, but they just don't want it mandated. And they don't want stuff in their backyard. And they don't want to hear that it's a catastrophe. And they're fine with local governments doing it, but they definitely don't want the federal government and they don't want taxes on it. So it's kind of interesting what these people that doubt climate change, what their reasons are for it. But there is a disconnect, right? There's a disconnect from all these people not wanting to move the needle. You're going to see a lot of these graphs. These are from the Yale School, who's done a bunch of like opinion polls and research on what people think. The majority of Americans, 58%, think that climate change and global warming is caused by humans. And if you look at the numbers, all those are different studies by different scientific journals looking at consensus agreements amongst scientists. So scientists, like 91 to 100% of scientists agree in all of these studies that it's human caused. But how come Americans aren't seeing that same, but they're interested in this, right? They're seeing it as a human caused issue, but they're not necessarily owning it, right? They think it is, but they're not owning it. And so it's hard. Like, how do we breach this disconnect and reach these people? Well, we definitely know that like climate change is human caused, and we're going to get into it. And it's really, when we talk about it, it's going to be talking about fossil fuels and the consumption of fossil fuels that we have had over time. And you're going to see that in everything, in all aspects of climate. Everything comes down to consuming fossil fuels and releasing carbon into the atmosphere. And that carbon was previously stored, right? Fossil fuels are stored forms of carbon. And as we release it, we're not capturing it at the same rate. And that's where it's coming from. So we've known about greenhouse gases for a long time, right? So Eunice Foote is an amateur scientist back in the 1800s. So in 1850s, right, women can't do science, women don't know anything. We part of the patriarchy, we got to keep them down. So Eunice, but as a curious individual, she says, I want to do some experiments. So she's in her backyard and decides to do some experiments. She takes different gases and puts them into glass containers. She has a glass container of oxygen. She has a glass container of room air. She has like wet, humid room air. And she has like carbon dioxide. And she takes these containers and she has them in her greenhouse and she just has them out, letting the sun hit them. And she measures temperatures in those containers. And she notices in the container of air is the same temperature that it is outside. So she's like, oh, same, same. Gets about 100 degrees in a greenhouse. She's like, that's okay. She takes the carbon dioxide container and finds out it's 120 degrees. It's a lot warmer than just natural air in her container. And she starts to write up her findings. Now, the problem is Eunice is in the 1800s and she can't publish because she's a woman, and she can't write anything about it because she's a woman. So she gets someone else to write in Scientific America about greenhouse gases and these findings. And that experiment led to future experiments, and you'll hear John Tyndall's name come up in the 1859 timeframe where he starts publishing some experiments about this. But we've known about greenhouse gases for over 170 years. And this concept was started by a backyard scientist, right? But we don't want to talk about Eunice or anything like that, right? We don't want to talk about science that's been going on for a long time. But when we talk about greenhouse gases, she's seen an effect, and we talk greenhouse because partly that's how the study came out, and that's also how um, the effect works, right? So are these particulates, right? Carbon dioxide, nitric oxide, methane are in our upper atmosphere. These greenhouse gases lie above our upper atmosphere. Normal sun comes in, and some of those natural greenhouse gases that we have, those normal gases in our environment, serve as a warming potential from us from space, right? Us as humans need to have a planet that has some temperature to it, right? We could not live in like, 20 Kelvin or something like that, some ridiculously low temperature. So the greenhouse gases keep our atmosphere warm at a place that we can live. The problem is we're adding more greenhouse gases into that atmosphere. And so as the sun's radiation comes in, as it's re-radiated from the planet, it's being bounced back and not allowing to escape into space. So that's keeping more energy and more warmth into our planet, the more we're putting these greenhouse gases into the upper atmosphere. And so we're doing that through consumption. And so you can say, well, where is this being consumed from? Well, there's four major areas if you want to think about fossil fuel use or greenhouse gas production: electricity and heat, agriculture, industry, and transportation. Now we talk agriculture. Agriculture, one of the big aspects is the creation of ammonia. So ammonia uses the Haber-Bosch process, which is a super energy intense process. You have to get temperatures greater than 1,000 degrees Celsius. So if you're thinking of like, oh, I'll just have my wood burning stove and I'll make ammonia, no, that's not going to work, right? You need something that is really energy dense that's going to create high temperatures. And we talk industry, we're looking at cement and steel. By far, steel is the most energy intense and the largest producer of CO2 of any metal production across the world. And cement, when you have to make that, you have to basically have high heat to make the building blocks that go into cement. So both of those are super energy intensive. And then we talk about the different greenhouse gases. This is almost like currencies, right? If you hear us talk in this course about carbon or carbon dioxide, they are in a sense one and the same. And it's like the dollar, right? And methane is the euro and ozone is the yen. And so there's different trade values of these, right? Carbon dioxide is the equivalence that we use when we talk about parts per million or a warming potential on the planet. But methane is 25 more potent molecule per molecule as a greenhouse gas warming potential. Ozone, more warming potential, 80 times as carbon dioxide, and nitric oxides are 300 times. Methane initially is like 100 times, but then drops down over time to about 25 times as carbon dioxide. So you can see how each of these has different warming potentials, but we use the term carbon. We don't use the term methane or ozone or nitric oxide when we're talking about those. Those are just parts of this. So when the carbon, you're saying like, Brian, the carbon's coming out from the ground and we're re-releasing it. Well, what is the carbon cycle, right? We have to understand what the carbon cycle is. Well, normally plants on this planet are full of carbon, right? And when a plant sucks in carbon dioxide to create leaves and to grow, it's removing carbon from the atmosphere. And then over time, those leaves fall off and the plant dies. And when it does that, it decomposes and releases carbon dioxide back into the atmosphere. So you have this kind of push-pull with plants. You also will have that with humans, right? As we grow, we are taking in carbon into our bodies. As we die, we decompose and release that carbon back. Also, the oceans are taking in carbon dioxide on a regular basis and re-releasing that carbon dioxide as well. And the soils do the same. Now, the soil is kind of fascinating, right? Because we look, and the oceans are some of the biggest sinks of carbon on this planet. We look and say, oh, that's a beautiful forest. There's a lot of carbon stored in that area. But if we look in the bottom left, you'll see that the root system is actually where most of the carbon is stored. And even if we look at grasses and plains and prairie or peat moss in places and mangroves, we see that's just a little bit of carbon above soil. But where the carbon's really captured is in the root system. And in those root systems, as we are starting to understand plants, they're even transpiring carbon dioxide into the soil as a store that they could pull it back later. So carbon underground is a great place for carbon to be, right? It modulates our atmosphere. But what we're doing is we're having an unnatural component to the carbon cycle. We are taking carbon that's been stored underground and we're releasing it in the form of fossil fuels when we consume those. When we deforest areas, we lose the carbon of the trees and we also lose the carbon in the soil. And so it's kind of it's a twofold where we're losing it. So we are, as humans, interrupting the natural carbon cycle based on what we're doing. So this is we talk carbon cycles and people talk about the cyclic nature, right? This is a common argument. This is a normal cycle over time. Absolutely correct. There are normal cyclic variants, and if we look over time, we're going to see that. So this is a graph that's running right now that's showing you every year the variation in carbon dioxide levels in red measured at Mauna Loa. That's an observatory in Hawaii that was established in the late 70s to measure parts per million carbon dioxide level. On the far left, you can see the 300s up to 430s. That is the parts per million carbon dioxide level. It is fluctuating, as you see, and it continues to rise. There is a seasonal variation. So spring, summer, plants grow. They suck a lot of carbon out of the atmosphere as they're growing. And as they grow, carbon dioxide level for that season goes down. And in the winter, all those leaves fall off and things die, things go dormant, carbon dioxide levels go up. So carbon dioxide actually increases in the winter and decreases in the summer every year on our planet. But over time, we're seeing that we have had, just since the late 70s, you can see this increase we have had that's been dramatic. And we're going to slowly start to pan out in these carbon cycles. In the bottom left, you'll notice that there are three things. There's carbon dioxide, which is in the blue line. The green line is methane, and the red line is temperature. And this is going back over 500,000 years. And you'll notice they all kind of correlate, right? As CO2 levels go up, methane levels go up, and temperature goes up. As CO2 comes down, temperature comes down. So there's a correlation. As our carbon dioxide levels go up, our temperature goes up. This is why we're trying to decrease the carbon dioxide levels. We're trying to draw that down out of the atmosphere, will help draw down temperatures and start to cool the planet. And as the moving graph is starting to go back, we're going to go back 800,000 years, showing these same cycles. So we saw where we were today. Now we're going back in the pre-industrial time is when we had our kind of normal carbon levels. We would go up to maybe 270 to 300 of a normal cycle carbon dioxide level. And since during the Industrial Revolution, we started to consume fossil fuels. Why do we consume fossil fuels? Because they're the most energy dense, easily transportable source of energy on this planet. And since that time, we have consumed a lot of fossil fuels, and that's leading to the sharp increase that has gone away from set normal carbon cycle. So even though we were pre-industrial in the 270s, maybe up to 300, now we're in the 400s and rising. So our parts per million continue to rise. So it's something that we have to think about is like, well, the carbon cycle has gone up and down. And you say, well, Brian, this is a cyclic nature. It's even just short term, right? Well, let's go longer term. Let's go 500 million years ago. So you're absolutely right. We have had higher carbon dioxide levels or carbon dioxide parts per million in our atmosphere. They were up at 1,500, 2,000. But that's going back 500 million years to a primordial soup. And I don't know about you, but I don't want to be in the primordial soup because when those carbon dioxide levels were up there, temperatures were at 16 degrees Celsius higher than what they are today. Well, what would that look like? Well, Phoenix and Tucson, instead of summers in the 110s, would be looking at summers in the 130s, 140s Fahrenheit, right? I don't think any of us want to be around at that point, right? I'm not going to be around if it's 140 here in Tucson. Like, that's ridiculous, right? It's not compatible with human life. So you're right. We did have higher carbon dioxide levels in the past. Absolutely factual statement. But over time, right, that carbon dioxide level is drawn down as life forms started to find, be created, whether that was in the ground or the ocean or on the trees and animals and algae and different things started to be created. And as those animals and plants were created, they sequestered carbon from the atmosphere. And as they died, those algae fell to the bottom of the oceans. And in the bottom of the oceans, they became natural gas and oil. And those forests and those animals that fell and died over time became coal, right? So the old forest became coal. These algae and other life forms became oil and gas, and they were sequestered under the Earth's surface. And we drew down carbon to the point where we cooled our planet to the last like 500,000 years where we reached a normal kind of cyclic nature. And then at the Industrial Revolution, we took that stored carbon and started to consume it and release it. And that's what we're at today. So overall, we're not as high as what we could have been, but we are way higher and trending upwards of the normal cyclic nature that we had come to a steady state on our planet. Any questions right now with that? I think that is like a key driver of overall carbon and understanding the movement of carbon on our planet. Any questions?
I had a quick question.
Yes,
How are we able to measure those CO2 levels from so far back? Is it through like ice cores?
absolutely. Great question. So we measure it directly now. Actually, we can't measure it because some people have turned off the Mauna Loa Observatory. Our government decided to do that. But the previous one, Jason, is so ice core samples. So how does an ice core sample work? In a sense, they take samples of ice, and over time, that ice is representative of the atmosphere because in the atmosphere, snow, all those particulates were there, right? Carbon dioxide. When the snow melted and landed and became ice, it captured what the atmosphere was like at the time. So as they go down, and since they're measuring the parts per million based on the ice and snowfall of each of those years, and each of those years then represented what the atmosphere was like. Similar to like a tree growth ring, right? You could look at certain years, the tree maybe grew more or less, and you could say, well, that was a wetter year or a non-wet year based on how much the tree grew. But yes, that's what they're measuring. So it's an atmospheric measuring based on the snow. As that snow became ice, it's captured at that year. And those ice levels basically built up over time. So it wasn't just like, oh, it melted again the next time. These are going to places where it's just an accumulating of snow and ice. Cool. Good question. Does that answer it?
It does. Thank you.
Cool. Any other questions? Sweet. So if we think of, we talked about solar radiation coming in, being reflected by greenhouse gases, right? This is a normal kind of energy that happens to our planet, right? Solar radiation comes in, provides a lot of energy to our planet. But our planet also emits a lot of energy. And greenhouse gases bounce some of that down. Clouds bounce some of that down, but a lot is still reflected off into space, right? And this is this normal balance we have with energy that is being supplied by the sun to our planet. Now, this is kind of our energy budget or balance, if you want to say. And if you think of energy, if you look at physics and chemistry, energy equals temperature. So we can look at both, and people say, well, it's warming. Well, warm energy, it is one and the same. And so, in a sense, our climate is energizing, right? So we have all this energy coming in. We are now changing because of greenhouse gases in the atmosphere and the consumption of fossil fuels, adding more to it that energy is not leaving our planet. It's staying in our planet. When that energy stays in our planet, it's got to go somewhere. Well, it's going into the oceans. That's why oceans are warming. You'll see it in ice. So ice is melting. In our planet itself, the land masses are absorbing a little bit of that as well. But our planet is also becoming energized. So when we talk about all this energy coming in, it's not being released, and you keep pounding it with more energy. Where's that energy going to be released? It's going to be released in storm patterns. It's going to be released in temperatures, extreme weather. So when people talk like, well, there was a cold front and it came across, the United States this year, there's obviously no global warming. There's still going to be cold fronts. Why? Because temperature, like anything, runs on a bell curve, right? You have hot days and cold days, and then there's an average temperature. And some days it's a little bit more, and some days it's a little bit less. But that's why there's an average. So you're still going to have extremes, but overall, the bell curve is shifting. So we are having more days of hot weather and more extreme hot weather, and we're having less extreme cold. And some of that cold is actually moving. And you can even talk with Tom tomorrow But there's even theories in terms of with weather that maybe the poles where they have been the coldest before, maybe those poles are going to start to split and the coldest areas will start to come down even over land masses. So there could even be new ice ages in certain areas while other parts of the planet may become even more desert. So it's fascinating. They're trying to, this is all new and they're trying to track and understand this. But on average, we're having a lot more hot weather than we are cold weather. And people also, right, we don't always equate one and the same. If a cold front comes through, it usually lasts for a couple days, maybe 3 or 4 days, right? Blows through, gets cold, and then gets warm again. When we hit a summer heat event, that heat dome sits maybe 7 days, 10 days, maybe 20 days, right? We're seeing really long streaks of high temperature. But as simple-minded humans, right, we equate, well, that was one cold front and one hot time. But there may be 3 times as many hot days as there was cold days. Yet we don't see those as different, right? We're seeing them as one versus one. So overall, we're still going to have cold times, but we're having a lot more hot days. And we're seeing this in cities across the country. So, what do you get, right? If you're warming the planet, what are you going to get? Well, you're going to get ice melting. Ice melting, guess what? Sea levels are going to rise, right? We're putting more water into the oceans as sea levels rise. As the temperatures go up, that creates more acid in the ocean. The ambient temperatures around are going to be hotter. You're going to have more extreme weather, probably more floods, probably more droughts, less cold days, more hot days, more fires, right? Your rainfall pattern may change. You may have drier areas and then all of a sudden get really extreme storms that drop ridiculous amounts of rain leading to flooding. So our whole kind of planet weather pattern is starting to change. And where are we seeing this? So this is a graph looking at warming over our planet over time, starting from the 1800s. Blue is kind of like, or white is no change. Red is average temperatures higher than normal. Blue is temperatures lower than normal. And you'll start to see we started at a blue kind of white area and we starting to go to yellow, which is like 1 degree Celsius up, and we're hitting red at 2 degrees Celsius up. And you notice there's an uneven warming. We're seeing warming more in the northern hemispheres and in places like France and Scandinavia and the Arctic and Greenland and Alaska and places that are getting a lot warmer. Part of that is they're not having as much cold days too, but they're also getting hotter temperatures. So there's an uneven warming of our planet in places that were cold. So overall, the core for all this, as we are increasing carbon dioxide levels through the consumption of fossil fuels, we're leading to rising temperatures, extreme weather, and rising sea levels. That's kind of the core climate science. Any questions on that before I get into just relating it now to health? Cool. All right, so let's just take extreme weather, right? How does this affect health? Well, you get droughts and you can get floods and heavy storms. Well, droughts are going to lead to like wildfires, maybe food insecurity, right? We're not producing as much food. Maybe the cost of food goes up. Now I can't afford food. So now you get racial disparities, you get socioeconomic disparities. Floods, they break infrastructure, they break roads. Maybe I lose my house. Now I'm homeless, right? Contaminated water. You have floods that come in. They basically you saw in Jackson, Mississippi, right? What happened? The clean water and the dirty water mixed. And now we got no clean water. So if we don't have clean water, it's hard to have sanitation. You get more infectious disease, diarrheal illness, things like that. Wildfires and smoke are going to lead to lung disease and increased respiratory illness. And if your house collapse on you, you could just die from straight trauma, right? A crush injury. So extreme weather can hit people on both ends, whether it's a large storm or flood or hurricane or typhoon, or the absence and just extreme high temperatures can also cause disease, right? We talk about sea level change, right? You're getting these higher temperatures. Well, sea level change is also not the same, right? Most humans live close to the ocean, right? We did that because we We started trading, and trade ports grew up all around the world because shipping was our first major transportation mode for long distance. Right? Before railroads, we had ships. Before planes, we had ships. Before highways, we had ships. And that's how, so people lived in those ports. Well, they still live there today. But because Antarctica creates its own kind of gravitational force, most of the ocean waters actually move from east to west. So if you take the Atlantic Ocean and the United States per se, places like New York, Miami, and Tampa are going to be more affected by sea level rise than San Diego or Seattle because the water is coming across the Atlantic towards them. Same thing on the Pacific. You're going to see places like Guangzhou, China, maybe Mumbai, places like Nagoya, Japan. They're going to be affected more than some of the West Coast cities. And that's just it's an east to west movement of water. So sea level change is going to affect different parts of the world first. And then if you want to look at the South Pacific, right, you have these small atolls who maybe are inches to a couple feet above sea level, they'll be even affected sooner. And that'll lead to migration, right? People are going to have to leave their homes because they can't live there because of sea level rise. Let's talk about just temperatures briefly, right? Tomorrow, we're going to get into temperatures tomorrow, but you know, we're seeing more frequent heat waves. I mean, was anyone in Tucson last summer? It was hot, right? I mean, it was long, it was hot. We used to see like heat times was like May to August, maybe September. Now we're seeing heat April to October. And I think most of us this last weekend said it was in the 90s, right? And it's February. Like, this is ridiculous, right? So we're getting more temperatures lasting longer periods of times, heating our urban environments, right? Because they're being affected more. And, you guys are taught like heat stroke and heat related illness and like heat exhaustion. But beyond that, heat's affecting cardiovascular disease, heart attacks, strokes, mental illness, schizophrenias, right? A lot of medical conditions are increased or magnified from temperatures. So really what we're seeing is this interconnectedness that climate change in our environment is a magnifier or becoming synergistically, right, harmful to a lot of disease conditions we already have. So you take climate change and you put that into the impact of now we're having more patients come to our healthcare systems. And our healthcare systems are already stressed, they're already overwhelmed, they're not getting funded, and now you have an increased patient added to that system, right? So now you're stressing the system more. Well, what's that going to do to the people in the system? They're going to get stressed more. They may not deliver as good a care. They may be not as interested and be overwhelmed. And then you have to look at things from a structural component, right? Whether it's our supply chain, whether it's where you're born and your social determinants of health, maybe it's your 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 neighborhood is getting destroyed because of a flood or a fire goes through it, right? Now you're homeless. Now you're putting more impacts on the health system too because you have increased needs. And now you're having water shortages or inability to get clean water, right? The interconnectedness of our social structures, climate, and our health system are apparent everywhere, right? They're all interconnected. And so understanding how one is affecting the other, but they're all being magnified by climate change. So what's going on in Arizona, right? Do we have any of these issues? Like we don't have earthquakes. We're fine, Brian. There's no typhoons here. Like we're in Arizona. Well, we got heat, right? You guys know we got heat. We got plenty of heat. We're going to talk about that. We got wildfires, right? We have wildfires in Arizona, but we'll talk about wildfire smoke. It's not just in Arizona. Its smoke can come from anywhere and blow into Arizona. So even though it doesn't have a fire here, we can still be affected by that. And then pollution. You guys brought up pollution. Well, Phoenix and Maricopa County and Pima County are both grade F from the American Lung Association for our air quality. So we have really bad air quality in both of our two largest counties in Arizona. That's going to affect a lot of people, right? And I don't know if anyone's had some runny nose or itching this last week, but I have. And allergy seasons are coming and they're starting to be longer, and we'll talk about that. But we definitely have allergies here in Arizona. And then we've brought up water. I don't, do we need water here in the desert? A little bit, right? Like we're living in a place where there shouldn't be as this many people, but at the same time, water is a big issue. So we are being affected on multiple components of climate change. And again, this is just bringing in that each of these magnifies itself, right? Higher temperatures leads to worse air quality, and worse air quality leads to higher temperatures because people are staying indoors and using more carbon dioxide in their fossil fuel consumption to run their AC units, right? All of these are interrelated. So even if you say, well, we're going to fix one thing, the interrelatedness in all of these is happening across the country. So that's kind of the complexity of how climate change and health, everything is interacting together and magnifying each other. So super stressful that everything's going bad and to hell in a handbasket, but there's hope. I want to start you guys with hope, right? Because if we just talk about the bad stuff, we're not going to get anywhere. So again, let's just look at like what Americans are thinking, right? How many people think that corporations should do something to help with global warming? 69% of Americans, right? Large percentage. How many people think that we should regulate carbon dioxide as a pollutant? 74%. Three-quarters of the country wants us to regulate carbon dioxide. But does anyone know about the endangerment finding and what happened a week or two ago? Anyone hear about that? So the endangerment finding, I'll give you a little history. Endangerment finding was in 2009. President Obama's administration came out and said that carbon dioxide, nitric oxide, volatile organic compounds are threats to human health. By saying that, they are endangering the human health and that we should regulate them in the EPA. And that was based on a 2007 decision in the Supreme Court of Massachusetts versus the EPA, where the Supreme Court said the EPA's job is to regulate carbon dioxide and these greenhouse gases if they are deemed to be harmful to humans. If they are not harmful to humans, the EPA does not have jurisdiction to regulate them. So, the EPA, that's when the endangerment finding came in and said, yes, they're harmful, so the EPA could start to regulate them. That's where we get things like changing our miles per gallon of a vehicle, right? We're going to start to regulate our carbon dioxide production, our consumption of fossil fuels, because we're going to change the miles per gallon because we want cars to go farther and not consume as much gas per distance traveled. So they'll change like the number for car manufacturers. The EPA can help with things like that. 2 weeks ago, the EPA under the Trump administration said the endangerment finding is no longer valid and got rid of it. Therefore, the EPA does not have to regulate any of these greenhouse gases. And so that's where we're at right now. So that was a big step away, but three-quarters of the country wants us to do it. So differing from the country. How many people want renewable energy on public land? Almost 80% of Americans want that, right? How many think that schools should be teaching the consequences and solutions of global warming, right? Three-quarters of this country. I think this is a huge issue. And I think like if we really want to solve climate change, a lot of you are like, well, I've never really heard that much about it. And that's a problem with our schools, right? We should be normalizing this conversation. Kids should be learning from day one in schools just about climate science, learning this so that climate change is like, yeah, this is what's happening, this is the cause. And their whole life they can go on knowing that as a baseline understanding. There is no debate. And then they can move forward with solutions and think about it, right? Americans want this. We just have, again, there's a disconnect. And why aren't we doing it? And this is part of the problem. How many people talk about global warming or climate change occasionally? Only a third of Americans, right? This is something that's, I think, important, right? One of the big takeaways from this talk is to be able to normalize these conversations. This should be something that we can talk about in a nonpartisan manner. We can talk about this as a health matter. We can talk about this is affecting all of us, right? All of us breathe the same air here in Tucson. There's nothing special, right? The wealthy don't get to breathe different air than the poor. We all breathe the same air. We all are exposed to the same temperatures. Maybe we go inside, but the outside temperature for all of us is the same, right? And it's affecting all of our health. This is something we have to normalize. We have to be willing to talk about this in conversation, not as a positive or negative, but it's kind of a fait accompli. Like this is happening. Let's normalize it. Like, okay, what can we do? Or this is a cool thing I learned about. Maybe this will be a solution that we'll talk about in the future. So this is something I want you guys to feel more comfortable to bring up these conversations, to maybe fact check some of your friends or family or community members who are like, well, that's bullshit. And you're like, no, actually, this is what's going on. Hey, we're not arguing over that. This is just what's happening, right? How do you start to have those conversations or bring this up in a more casual manner? So in terms of solutions, you're going to see kind of a divergent. There's individual decisions, and when we say individual, it's like each one of us, but there's also like maybe this individual organization is doing that because they're not, they're associated with their own plans versus a policy, right? A policy is a governmental, whether that's local, state, federal, governmental coming down and saying, this is what we should do, this is what's going on. So let's talk about like the benefits of kind of individual versus policy. Well, individual decisions, right? The first thing that we all should be able to do is vote, right? We got to get people to vote. Healthcare professionals are not great at voting. So there's like a voter. So I have a badge that I wear during election season to allow patients and other health professionals to scan it to sign up to vote. It's a nonpartisan, it's just getting you registered to vote. But us voting makes an impact. Only about half of residents vote, half of med students vote, half of attendings vote, right? We're huge voices. We should be ones that influence the policy decision makers, right? It is important for us with the knowledge that we have to help educate others and ourselves, but then to go out and say, this is an issue. We need to vote and put the right people in place. If you don't put the right people in place, you're going to get what you get. And so part of that, to be able to do that, we want to educate ourselves. And so you're all doing that, right? You're here in this course to learn more. And I bet in 2 weeks you will have more knowledge than you did coming in. And that's the goal. And when you're more educated, you feel more comfortable talking about it. You feel more comfortable advocating, right? If I asked you to give a presentation on a topic you didn't know anything about, you'd be like, not interested, right? But if you are really knowledgeable about something, right, you're going into you now, I bet, can talk to a lot of first year med students with a lot of knowledge about med school because you're pretty spun up on what happened in med school, right? You're very educated in that. So the education allows you to advocate and educate others. And then also understand that you're all going to be community leaders. You are going to be people serving as an example. So your behavior matters, your decisions matter, how you hold yourself accountable matters, right? If you show up with a plastic water bottle and drinking out of every day, doesn't look good. You're showing up, you're refilling your water bottle, using a metal reusable water bottle, that's impacting others beyond what you think, right? So your decisions matter, and you can serve as that example to influence people. They will look at you as you're like, I'm just a med student, Brian. I'm on the bottom of the chain. No, you will be a resident and you will be an attending and you will be a community leader and you'll be looked at and looked to for others. So know you will have this power and it's coming. So you need to use that power for good. Let's talk about 5 quick examples, right? So if you want to say, what are the most impactful choices? I'm not asking you guys to get rid of plastic straws. I don't care, right? It was a great little movement, but it's not moving the needle. Big 5 things to move the needle. One, generate your own power. So in Arizona, solar. You could do wind, maybe if you lived up in Flagstaff or something, but there's just not enough wind here. Other places in the country, absolutely wind would be totally reasonable. Solar, pair it with storage. So batteries, solar and batteries, become your own power plant. Huge difference maker. Second, the car. doing driving trips. So fly less. Obviously, if you're going to Europe, you're going to take a trip. I don't have a problem. You're going to fly. You can't drive there. But maybe instead of flying to San Diego, you drive to San Diego. Huge difference in CO2. So make some driving trips. I pack up my family there and we drive 3,000, 4,000, 5,000 mile trips during the summer. And we do that all on a number three, sustainable transport. So we use an electric vehicle to do that. So sustainable transportation, lots of benefits of this. And this is not just electric vehicles, but switching from internal combustion engines, so ICE vehicles to electric vehicles. But also if we advocate for our patients for walking or bicycling to work, huge health benefits, right? More than just like, oh, I'm not spending money on the car. I'm not spending money on fuel. Now I'm walking and biking. Guess what? Heart disease, diabetes, blood pressure, high cholesterol all start to go down with those kind of behavior changes. But if not, maybe they can't afford it, right? Public bus or public transportation, another sustainable transportation method. So number three, sustainable transport. Number four, plant-based diet. Brian, I like barbecue. I like Thanksgiving turkeys. I like barbecue. I like Thanksgiving turkeys. I have turkeys on Thanksgiving. I eat barbecue. But a plant-based diet is having a heavy plant-forward diet, right? So I made some changes and I'm kind of a weekday vegetarian. I'll go multiple days without eating any meat, and do that. Totally reasonable, right? Makes a big difference. Meat and beef is the worst, right? So we're going to hear from Jen, but beef is the worst food per se for the planet of all the meats. Pork is better, and chicken is better than that in terms of making decisions. Or changing your portion size, right? Instead of an 8-ounce steak, I eat a 6-ounce steak. 25% less CO2 emissions from that food choice. Simple decisions like that. This is a picture of the planetary diet. So the planetary diet comes from the Lancet. Lancet, right? Big organization out of the UK. You can see the pictures, lots of fruits and vegetables with this. And the reason they're looking for that is they made a planetary diet that could be applied to any culture and their normal traditional food. So whether you're living in Asia or Africa or Europe or South America, this was a diet that you could apply, and it still included meat. It just decreased the amount. So a plant-based diet or plant-forward diet, maybe you go meatless Mondays, maybe you're weekend vegetarian, something like that. And the fifth thing is having less little carbon footprints, right? I already showed you a picture. My wife and I had 3 kids, so I've obviously failed this one. But if you make the decision not to have kids or people having less kids, that's obviously a large carbon footprint changer. So generate your own power, fly less, sustainable transport, plant-based diet, and then doing less kids. Other aspects of solutions. I'll try to bring this up a couple times, but you can't take on all the climate change all the time with all the energy that you have, right? Find something to get engaged with and start with a baby step. The first thing is what brings you joy. This is from Ayana Johnson, who talks about where a lot of this information comes from too, and How to Save a Planet podcast. But what brings you joy? Think about what you enjoy, right? And then what are you good at? And what's the work that needs to be done? Right? If you're like, I like to cook, maybe I'll take the planetary diet. That brings me joy. I think I could do this and I could make that. Versus you're like, I love to bike ride. Maybe I'll try to bike ride to work. That's the choice I'm going to make. You don't have to make all the choices simultaneous, but if you find something that brings you joy and that you're good at, the chances of that being where you get involved in climate probably is going to be more sustainable, both for you, and for your decision. So we looked, that was kind of individual policy stuff, obviously voting the right people in, but being involved, like showing up to things, calling in, writing, whether it's writing like a letter to the editor for a paper, writing to your congressman, calling people, being engaged in the public policy process. You can join advocacy groups, so you can join us, that's Arizona Health Professionals. There's a QR code if you want to join, or right, find other groups that align with your interests, right? I'm interested in water, I'm interested in, food deserts. Cool, get involved with that. How can I how can I make differences or enact policies that are beneficial for my community? And when we look at like individual and policy, you can say, what's better? Well, policy in some ways, right? If I put a policy impact, I can impact a lot of people, right? So, an example, China. China said in the 90s was like at 3% renewable energy. And now they're over at 30% of their energy is renewable. Why? Because they made a policy decision in their Politburo and said, we're moving forward and we're just doing this. The United States in the 90s was at 22% renewable energy, and we're at 27% today. We just don't have the same policy push and movement on those fronts. So policy can affect a lot of people, right? You give incentives, things like that. Individual action, if magnified, can affect the same number of people, right? If I do this thing and teach this course, and you guys, there's 15 to 20 of you, decide, yeah, we're going to go do something, and then each of you impact two people, and those impact two people, right? And you start magnifying down a tree, you can get a lot of people involved really quick. But that's kind of a grassroots component. So policy is obviously better, but harder to enact. Individual decision making may not be as impactful immediately, but could be more sustained and get to more people faster. So it's kind of a trade. When you get involved, right? This is also from the Lancet. So knowing that being involved in climate is not an easy thing to do, right? This is not like you're going to come in and tell people and they're going to listen to you all the time. You have to have right. You're going to set a target on what something that you want to do. You're going to have a strategy. You're going to use tactics to try to get there, and you're going to think it through. And maybe you'll get a win. Maybe you can get something, right? So at South Campus, we found out with our sustainability group that we only recycled cardboard boxes. And we said, why is there not a recycling program? And they're like, well, we don't have one. So we tried to get a recycling program and we're able to get it. We met with waste management and leadership and we're able to get a recycling program. So we got a win. Now we can recycle some cans and some plastics, paper, things like that. So that was a win. It was great. But we tried it for solar, right? So we had a whole plan getting solar panels on the North Campus garage. It was going to be covered in solar panels. I engaged with a community, a health partner who's working with hospital systems. We were going to do that. Everyone was on board. Financial VPs, the operations VPs were on board. And then in September, they said, we're kind of done. And why was that? Well, there were cuts to Medicaid that were going to affect Banner's budget, and they couldn't do it. And they went cold turkey and didn't talk to us again. And that was kind of disheartening because we had done this work and we had done everything. So you're going to have wins and losses in this, right? You're going to try to move the needle where you can, but part of it is knowing that there are going to be wins and losses. You are going to have to keep working the problem, right? This is a complex problem and you have to keep working the problem. You're going to talk to other people. You're going to get, gather up your support as best you can and use it and try to get as big a target as you can. But sometimes little baby steps is also totally fine. So it's a complex thing, but it's going to take, like with everything, right? It takes time and money. And so it's going to take some of your time. It's going to take other people's money to move this forward. But as we do this, right, as we work the climate problems, we're going to know that when we get a healthier planet, we're going to have healthier people. The interactions with improving climate, improving health, right? You guys were mentioning even right, you said COVID, what happened? Everyone stopped driving. So we take the four components, transportation, energy, agriculture and industry. We took transportation away and the skies cleared up. And guess what happened? I was working in the ER. Do you know how many heart attacks we saw? Didn't see them. Do you know how many strokes we saw? Didn't see them. Right? Things started dropping off. Respiratory illness, we saw COVID. I didn't see asthma exacerbations. I didn't see COPD exacerbations because they're all tied to air pollution. Imagine that. You clean the air, so you make acute changes. The planet's going to take a long time to cool. That's going to be a harder thing. But the health effects are going to be seen quickly. Just like if you stop smoking, you'll notice health effects in the first weeks to month after you stop smoking. Guess what? If you stop some of the production and exposure to air pollution or extreme heat, we're going to see health effects in the first few months immediately. So that's kind of the cool part. These climate solutions become health solutions that we're going to see very fast. So just know, right? It's real, it's us. Experts agree it's bad, but there's hope, right? Those are kind of the climate facts. You're going to hear that. This is simple messages. Ed Maybach's a professor emeritus now at George Mason, but really good in the climate health space talking about this in messaging. Simple messages repeated often by trusted professionals like you, hint, hint, make a difference, right? So that's where we're going with this. We're going to talk about these vulnerable populations here, but today, hopefully, I've given you a background of just climate and change. We've talked about the carbon cycle, how things kind of move over time, over 500 million years, a long time, how we stored carbon, but now we're releasing it through the consumption of fossil fuels. That's warming and energizing our planet, right? We're seeing that, and that's relating to health effects. But we also talked about solutions to those health effects and to our planet, knowing that they're one and the same. As we affect climate, we're going to affect health. And so as we start to make those changes, we're going to start to see improvement in our health outcomes in our communities. Cool. That's all I got. Any questions? Sweet. Javi asked about more data centers. Oh, data centers. Fascinating. Um, are you asking for more data centers, Javi, or asking about the data center question?
No, sorry. I was just mentioning, like when you were talking about just the air quality, like in Arizona, I live in Surprise, or I grew up in Surprise specifically. And so all of that land, well, a lot of that land is being used for like these data centers